Okay, we're going to talk about containers. And the gentleman is Kenny Parsons. He's with Trace3. They're a VAR that I've known for a long time. You may know they had an acquisition earlier of Set Solutions. Really ace people. They know their stuff. And, you know, containers is one of those, I'll call it a black box area where in many companies the attitude is, oh, it's a container. Don't worry about it. The environment will handle everything for you. Not a problem. DNS, no, don't worry. We'll let the container handle it. Security, it's built in. Don't worry about any of that stuff. Well, Kenny is going to tell you the straight scoop. Kenny, it's all yours, bud.
Thank you very much. Appreciate it. And I don't know if you meant to do that intentionally, but the title of the talk is Blackbox Containers. So I need to disconnect from the Wi-Fi. It keeps coming back up. Real quick, I wanted to talk about the origin of the name Blackbox Containers. I was having a conversation with a coworker of mine, and he had a very similar experience. He wanted to talk about how containers were difficult in a traditional security environment, and he couldn't use his standard set of tools. He didn't know what was going on inside of them. What were they doing? They were short-lived. They were exiting before he could really find out what was going on. To him, they were a black box, and that got me thinking, yeah, you're right. We can't consider these as normal parts of our environment. We have to treat them a little bit different. For sake of time, I'm going to skip through. Thank you for the introduction. I did want to cover some real quick container basics, real high level, and then we'll kind of get into some of the application. What are they, what are they not, and some different types. So the textbook definition is a container is a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably in one computing environment to another. You can read the rest, but basically it solves the problem of it works on my machine. I don't know why it's not working on yours. Everything is self-contained inside the container, hence the name. So what are they not? This is more of a pet peeve of mine, but a lot of people, when they're trying to rationalize what a container is, their mind immediately goes to it's like a VM, but it's not. So VMs abstract hardware. Like a hypervisor will run multiple kernels, multiple instances of a virtual piece of hardware. But in contrast, containers abstract software through the use of an engine or a runtime like Docker or all these others that we'll talk about. So the prime difference is that containers do not have their own kernel. The runtime will share the kernel of the underlying host rather than like a hypervisor creating a machine with each with its own kernel. Obviously, sharing a kernel is going to be a security implication, so we need to talk about that. That'll be on our list for later. So some quick advantages. This is not every advantage out there. These are just some personal advantages that I've found. Resource efficiency, so we can get some process level isolation, and using the host kernel, sharing the host kernel means we have less overhead. So instead of spinning up 10 VMs, 10 kernels, we now just have one, and we're sharing that. And again, there's a security implication there. Portability. In the definition, we talked about everything's packaged up together, and it's all isolated or self-contained. That is portability, in my opinion. All the dependencies are all together, and they're all bundled in. That means we can easily move our application from different environments, dev, staging, production, whatever, and act exactly the same. As long as we have the container runtime, we can do that. Continuous deployment and testing is another area where that has seen significant improvement and growth because of microservice and container technology. The ability to have consistent environments and flexibility with patching. So in a microservice example, I just have to patch or work on one particular component rather than the entire monolith. That has greatly increased the speed at which things can be delivered. So again, that's not an exhaustive list. Those are just some of my personal advantages. Some popular container runtimes. LXC, a lot of people don't think of LXC actually. It's not as widely used, and we'll talk about why. Docker and Podman. Docker and Podman are almost like interchangeable. Podman was actually released to be a slightly more secure, better version of Docker, a little bit more opinionated in its security. But mainly that's what we'll talk about. And then further on in the presentation, we'll pretty much exclusively talk about Docker. And then I do want to talk about the operational impact that this has had on businesses. So we'll talk about some common uses, where we see them, runtimes and orchestrators and the differences between those and how that has impacted the business, and then again, development. So some common uses. First would be OS virtualization. Now remember, I said a container is not a VM, but LXC does kind of fit into this. It's most suited to replace a VM. It still shares the kernel, but it has its own standalone environment. Again, think of VM, but at the kernel level, not at the hardware level. Docker, however, is the most popular for microservice. So that's a hot topic, that's a hot term, it's a buzzword, but it's a microservice or a distributed architecture. So first, what is a microservice? It's a monolith that's broken into smaller, independently scalable services. Each container runs a portion of the monolith, hence microservice. What this allows you to do is to distribute core components of the application across maybe multiple nodes, different regions, whatever, but they still act as one single cohesive application. Microservicing allows developers to, as I mentioned before, they can just focus on each individual component rather than the whole monolith, and all they have to worry about is that part and how it interacts with the rest of the application. There's a lot of really good benefits to microservices and how we release and do testing and development and our release models and schedules, but for sake of time, I'll move on. I do want to talk about the difference between Kubernetes and Docker. When people are first learning about containers, and obviously Kubernetes will come up, it's easy for some people to think they're kind of one and the same, or they're somehow like interchangeable. They're not. So Kubernetes is basically a big API for managing containers, Docker being one of them. In fact, if you use a default installation of Kubernetes, it'll usually use Docker under the hood. Like if you use all of your deployment methods or any of the cloud providers, they most of the time use Docker under the hood. So Kubernetes is an orchestrator, and that will have some security implications as well, so we'll talk about some of those. But it uses Docker under the hood. It is not necessarily a replacement for Docker. So where are they best used? Where do we see containers? Where should we focus? Well, first, services that can be easily segmented. I feel like that's an obvious one, but let's talk about that. And from here on out, by the way, I'll pretty much exclusively refer to Docker or an orchestrator, and I'll pretty much refer to Kubernetes. The reason why is that Docker has its own philosophy on containers and how they should be run, a philosophy that I tend to agree with. So anyway, that's what I'll refer to from here on out. So containers, best used in microservices. So for example, I worked with a company that had been around for like 20, 25 years now. Actually, they're just now celebrating their 25th anniversary. And they developed essentially a web UI to build websites for governments, hospitals, schools, things like that. For all intents and purposes, it was basically a web server and a database. And it was a monolith, and there were other parts, but it was all installed on one big machine. And I started noticing a problem where these companies, depending on their business, they would have peak times, and the servers had to be able to handle that load at peak times. So we were oversizing these servers massively. I mean, some of them were 90% oversized. It was huge because they just had such high peak times at certain times of the day. So I thought, well, hey, what if we can utilize the advantages of an orchestrator like Kubernetes and its features like auto scaling based on load, so that we have a minimum set to handle our normal load, and then it can automatically scale out, scale back down. Well, the problem with this application was they had developed it for 20 years with the assumption that the database was installed on the same host as the web server. And so by removing the database from that host and adding network latency, so you're segmenting it off from the monolith, that latency caused the application to become unresponsive because they had always assumed their database calls would be instant because they were using local sockets. So that was an application that wasn't suited. It looked like it was on the surface because you can easily segment a web server from a database, but it wasn't suited because of how it was developed to be microsegmented. So there's not a use case all the time for microsegmentation. So that's just one thing. Those who are against microservicing, maybe it's just they're not used to it, they don't like it. That's usually one of the arguments that they give is like, not everything needs to be microsegmented. And with that, I agree. but there are opportunities to improve our developers' code base and things like that to make it suitable for microservicing. Ephemeral workloads would be another great use of containers. Maybe your application is just a function, and containers can perform these functions, input, output. If you're not already using container tech and you need a function-like app, obviously there are cloud services for this, Lambda, Azure functions, GCP functions, things like that. But if you're in a container environment, you can leverage these already. So for example, if we look at a company like GitLab, they have a Kubernetes installation where you can install the whole application in Kubernetes. And when you want to run a build pipeline, they usually will spin up a runner. Usually, if it's a standalone application, it's a dedicated node and it handles all the build pipelines and things like that. Well, in a Kubernetes environment, instead of having that node resource always up, ready to run and do a build pipeline, you can instead just ephemerally spin it up, run it, and then it quits. You save your artifacts, you upload it to the cloud or whatever, but that workload is now, it runs and it's done. So that's another great use case for containers. But again, if you're not in a container environment, consider like serverless, things like that. And then another place, ad hoc tooling. I like ad hoc, using containers and ad hoc tooling. For example, if there's a Python version I don't want to work with, or excuse me, an Ansible version I don't want to install on my machine, it's just easy to throw it in a container. I put everything I need in there, it just runs. I did that a lot actually, and so containers are a good way to do that too, instead of putting old versions of Ansible on my machine in my example. Yeah. So it might be hard to see in the back, I apologize, but I'll explain. But a container image, the reason why I'm going through the basics here is because it does have security implications of these, let's call them artifacts, layers really, of the Docker file. So Docker uses the Docker file, it's a plain text, and you basically are just, it's infrastructure as code, essentially, of what your container is supposed to look like. This is not a well-optimized container. Please don't use this as like a perfect use case to run in production. This was just an ad hoc tool that I wrote, but it lends itself well for the example. Each layer is just a set of commands. In the first layer, I am importing layers from somebody else's work. In this case, I'm importing Debian's layer of their Bullseye Slim, so their Bullseye image. So they've done the work, they've built all the layers, however many 100 layers that create that image. I import that and I use that as a starting point. And then each layer after that are just non-interactive CLI commands. And then after that, I'm copying in some code base, I'm changing the directory, and I'm switching my user from the default root to a non-root user and setting what the command is to run at runtime. So, some really cool things happen when we do layering. Number one is layer caching and layer hashing. So every time you start a new layer, the previous layer above it gets cached and hashed. If it changes, like you adjust something, add in another package, that layer now changes because it gets a new hash. It gets recalculated every time. So you can use that when you're considering security. Did the hashes change? That way you know your container is immutable. It's not been changed. The downside of this is if you include maybe a proprietary code base or a secret of some kind, and we'll talk about that here in a second, and you don't get rid of it before you leave that layer, it gets read-only cached. Even if you delete it in subsequent layers, you're not really deleting it. You're just masking over it. So understanding how these images are built, obviously it leads to, oh, I shouldn't leave secrets in there and just cover them up at the end. We'll use that one as an example as we talk through some complex security considerations. Images, registries, runtime and the engine, and then the orchestrators and hosts. Those are the kind of the four main areas that we should cover. So images. First, we should really be considering in an enterprise upstream vulnerabilities. So there's been a lot of supply chain attacks in the last year. Think of like 3CX, all these types of companies getting supply chain attacks. And if you remember from our previous example, I am trusting Debian that they have no vulnerabilities in there or that I can mitigate them. I know what's going in there. I'm importing their layers and I'm trusting them. Even if I'm updating them, I've got to make sure I know what's in there. And so as an enterprise, we've got to understand and build what I call a base image chain of trust. What are we allowing into our environment? developers, it's really easy for us to go, well, there's already an image out there that has this package that I want or the setup that I want. I'll just use it, tweak it, add our stuff, package it up, ship it out. Well, the problem is that developer that's maintaining your base image, are they updating it? Let's say the latest curl vulnerability that's just come out over the last couple weeks. Have they patched it? Are they a full-time company managing, having a VM program, checking their images and making sure they're not introducing vulnerabilities in people who are using their work, that they're offering it to people? So establish a base image chain of trust, whether by policy or by even some control that doesn't allow certain images to be used, whether at build time, shipping, or run. You can be checking all that stuff. So when you're building, you can say this build will fail if it's not using an approved base image, things like that. Misconfigurations are a common way that vulnerabilities, I say that in air quotes, it's not really a vulnerability, it's a misconfiguration, but an exploit can be used or an attack can happen, and there's really easy things to miss. Not using correct permissions, so principles of least privilege. Have you run that container as an elevated user? Is the user inside of that container running as an elevated user? Is it switched from the default root? It's because you have to take an action to switch out of root. So it's really easy to just use the default, which is root. So have you used principles of least privilege? Have you switched your user? On the underlying host, have you set up rootless mode where you don't have to require the Linux user running the Docker commands if you're just using straight up Docker? Have you made it so that they don't have elevated rights to everything else, that they're just allowed to run Docker commands? The Docker socket's another one that you'll see in standalone Docker runs where they say, oh, attach the Docker socket to the image. Well, the Docker socket's connected directly to the kernel. You never want to do that. If you're doing that, you probably are building the image wrong. In orchestration environments, these same things still apply: user switching, incorrect permissions, access rights. Instead of sudo, I would talk, Kubernetes API, service accounts. Are we doing proper permissions on our service accounts? Are we doing managed identities for connecting to the Azure cluster? Things like that. So all of this misconfiguration still applies even if you're talking about Docker itself or the orchestrator. Vulnerable binaries. So much like the upstream vulnerabilities, the packages that we are installing or that we're building, maybe our proprietary code, are we developing securely? So that's where companies who are doing SAST and DAST, like the previous presenter up here, talking about that. Are we developing things securely? Making sure we're checking for that and using tools. We'll talk about some tools and vendors at the end, even open source stuff that you can be using that will help you make sure you're not introducing your own vulnerabilities into your own images, and how you can have a good VM program to catch anything that comes up after the fact. And then build secrets. This is something that when I first started working on complex builds that required proprietary code, it was new to me of how do I need to pull like from a Git repo, a private Git repo within our company's infrastructure. Well, how do I do that? I need to provide it with a credential, a token, a service account, or something like that. How do I securely do that without hard coding it into the Docker file? Because believe it or not, that still happens. I mean, how many times have any one of us running a script, we just hard code the password somewhere in there, or have a config file with a hard coded password somewhere? How can we do these? Because these are happening in non-interactive environments. They're all happening automatically, supposedly. I mean, if we have like a DevOps build pipeline or something. How do we introduce secrets that are required for that build securely? Because again, if we put it in that Docker file and we don't remove it or we don't handle it properly, it gets read-only cached and it can be extracted later on. So start with your images. Make sure you're just doing some basic vulnerability management here and establishing some policies and procedures on what are we allowing in our environment. And then the next stage is in the registry. In particular, our RBOC controls, authentication and authorization, around a few major like CRUD operations that we can have on our registry. So when you build an image, you push it to a registry. That's where your clients can pull it from. In particular, you have push and pull. Those are the two big ones, and then delete. That's obviously a big one, but make sure you have proper controls around that. Who's allowed to push images to your registry? Who's allowed to pull from your registry? And then who's allowed to delete? Having proper controls around that, and I'll explain why here on the next slide. If you're using your own registry and not a SaaS-based registry, make sure you have encryption at rest, encryption in transit. Most of the SaaS registries will do that automatically for you already, but double check. Make sure all those configuration settings are turned on. The reason why I talk about authentication and authorization, here's some quick stats. I got an excerpt from, this is actually from 2020, but like 2 or 3 months ago, Aqua released a very similar report, and it showed the exact same problem. It's not getting better. In fact, it's getting worse. All these numbers are basically still the same. So I'll read the excerpt, but here's the snapshot of it. It says, our research identifies 941 Docker registries exposed to the internet and 117 registries accessible without authentication. There are a total of 2,956 repositories and over 15,000 tags in these registries. Out of the 117 unsecured registries, 80 registries allowed the pull operation. No authentication, just they could pull all of your code. 92 allowed the push operation with no authentication. And 7 registries allowed the delete operation with no authentication. So without looking into the image content, they said we could attribute about 25% of the unsecured registries by reverse DNS lookup or CNAMEs into TLS certificates. So this is publicly available information that they just happened to look like no one else was. They say the owners of these registries range from research institutes, retailers, news media organizations, and technology companies. Some exposed registries had more than 50 repositories and 100 tags exposed. So a lot of code being exposed here. With all the source code and historical tags, malicious actors can design tailored exploits to compromise the system. So for example, all of those pull operations, they could pull down your code and open it up and look at it and figure out, how can I attack this company? How can I attack this application? Because they had access to the source code now, because the pull operation was unrestricted. If the push operation is allowed, benign applications may be replaced with images with backdoors, so supply chain attacks, right? These registries may also be used for hosting malware. If the delete operation is allowed, obviously we're looking at DDoS attacks here. And one other note that they made, which is very important, as each registry is typically accessed by multiple clients, all the clients who pull, and in my opinion, all the clients who push, and run images from the compromised registries, we immediately have to assume they're vulnerable. So secure your registry. Even if you're using SaaS-based and you've got encryption at rest and in transit all taken care of, make sure you are auditing your RBOC controls. You know, it's easy in an Azure group or an Azure DevOps pipeline or in any other of the clouds to have overly permissive groups. And are you allowing the right people access to your content? The keys to your kingdom. Our container runtimes themselves are just binary, so we need to make sure we're updating the runtime. I feel like that one's obvious, but patch, please. The configuration of the runtime, again, misconfiguration often leads to more issues than actual vulnerabilities. But are you running in rootless mode? Are you, correct permissions of the user allowed to run that? Like, are they able to use sudo? Do you have root-only file systems? And this is really hard to have a root-only file system of the underlying host, because a lot of things don't expect that. It's really hard to configure this, but we'll talk here at the end actually how I was able to get remote access to an AKS cluster and install and run scripts on the AKS worker node. So I was able to get root on a worker node, and it's because they weren't using read-only root. When you're running Docker on Linux, and this would apply to Kubernetes as well, because most of them are running on like Debian, Ubuntu, or purpose-built Linux distributions. Make sure you're dropping Linux capabilities, all the set of permissions that it's allowed to do within the Linux system. Cap, netadmin, things that it just doesn't need to do, set GID, set UID. If your application doesn't need to be doing that on the host, drop it. So fine-tune all the Linux capabilities, and then please stop running things as privileged. Containers most of the time don't need to be run as privileged. If they do, air gap it, don't expose it to the internet, but most of the time you don't need to do that. And then the last area to check on is the orchestrators themselves and the hosts themselves. So the last one kind of ties in here, but secure the host, obviously. Follow basic host hardening, protect against container breakout. Let's see here, orchestrator security scanning. So typical security measures still apply to an orchestrated environment. Are you setting up proper networking, firewalls, things like that? All of that still applies. Some of it's just abstracted away by Docker and Kubernetes. There's those abstraction layers, but the concepts still apply. Are we having proper isolation within namespaces? Do we have proper networking communication between those namespaces or between the services within namespaces? So standard standard security rules still apply here. It doesn't mean just because it's in an isolated environment, like you were saying before, that it's secure. You still need to be doing all that stuff. API access, I'll talk about that. Again, Kubernetes is just a big API. It's a very powerful API, and it can be very complex. So make sure you're auditing your API and your IAM access. I don't think we need to talk about this much more, but having dedicated service accounts and proper secrets management like HashiCorp vaults or any of your big cloud key vault management systems, use those to help build secrets and access to the clusters and things like that. Now I want to talk about the container lifecycle. So we've talked about the different areas where we should be considering security. Now let's look at the whole lifecycle of a container. And this is my opinion. It's pretty generic, but it covers it from inception to ending. So our code and build, shipping and storage, and runtime. So at our code and build stage, this is where buzz term shift left, right? Yeah, left. Okay, that's left for you guys. Consider security from the beginning of the development, including the coding of the Docker file, the code itself that you're importing, your image chain of trust, all that stuff that we talk about. Scanning at build time for layering suggestions. Perhaps you can have a linter looking at your Docker file going, hey, it looks like you might have a secret file somewhere in there, or it looks like you didn't clean up or optimize that image for space or storage. Those linters exist and they can help you with that. And I'll actually show you an open source tool you can use to do that. But they can just help you identify common misconfigurations. Knowing how to use build secrets, we've already talked about that. HashiCorp, all the cloud key vault systems use those instead of hard coding them. Then at shipping and storage, this is where we're using the registry. And so obviously, like I already mentioned before, secure the registry, secure the image source. So whatever computers, hosts, DevOps pipelines, whatever's doing this, make sure those sources are secure. So if I'm developing on my laptop, I need to make sure my laptop is secure, that we have proper endpoint detection and response, that we have proper antivirus, and all of those controls on this computer, because if this host is not secured, everything that comes from it, I have to assume, is not secure, okay? So secure the image source, and we already talked about securing the registry host itself and the storage if you're hosting it yourself. But again, if you're using the cloud, just always double check all of those. Double check the storage accounts that you're storing information in, and make sure there's proper RBOC controls on that, okay? So kind of your CSPM talk will help you there. And then finally in the run stage. So this is a really fun area. There's a lot of, there's some companies right now in the market that are doing some really great things in this with really good open source tools. And this list is not exhaustive. These are just some high level things that you should be considering. Admission controllers is specific to an orchestrated environment. So like Kubernetes, for example, you can set a policy that the admission controller will look at, and it will say, like, if an image is running with a particular configuration, or let's go with an easy one, if it's running as the root user, like they didn't switch the user, the admission controller can have a policy to block that. Doesn't even let it run. Doesn't let it enter the environment. So admission controllers you can write policies for the admission controller to really fine-tune what's allowed in your environment. Your image chain of trust, what images you're allowed, what tags you allow, all that can be done in admission controllers. Image pinning, very similar to the controllers, is you basically write a policy, or you write, it's an operating procedure here, to say, instead of using our image and the tag of latest, so a lot of you are probably familiar with that, you can add a word tag, a mutable word, and most of the time it's latest. That's default by all of them. They all use latest, but you may have dev, you may have latest or production or something. That mutable tag is open to a possible mistake. Let's just say someone's building a dev image and they accidentally tag it as prod and push it. Well, now you have a dev image running in prod because you're using a mutable tag. So instead, use an immutable tag. Use the hash value. So once a container is created, it gets a hash value. It's immutable. Use that instead, so you're always guaranteed to run the right image in your production environment. And then network security, we talked about that. Basic networking security principles apply. Subnetting, IP, firewalls, all that good stuff. Make sure you're doing that. So some tooling considerations. So this is in no particular order, and also it's not exhaustive. These are some companies that I know I've personally worked with that have open source free tools even. So Sysdig has Falco, which can run in an orchestration environment, and it watches everything that's going on in your environment and gives you complete visibility, and it's completely free and completely open source. They also have KubeShark, which is Wireshark for Kubernetes. You can inspect all the network traffic now natively within Kubernetes. So very powerful and also free and open source, completely free. Actually founded by one of the founders of Wireshark, who is also, I think, one of the partners or one of the founders of Sysdig. So Sysdig is committed to this open source and community. So great company there with great products. Same thing with Aqua. They have time and time again committed themselves to open source and sharing. They have several open source tools, Trivy being one of their most popular. That you can usually throw into a build pipeline and get an output of all of your misconfigurations, your vulnerabilities. So it's heavily used in vulnerability management programs. Again, 100% completely free with even amazing options that you can integrate into an enterprise environment. And a lot of enterprises do because it's a very solid tool. Sneak, obviously everybody knows who they are. Even up until a few months ago, they were integrated into the Docker CLI for security scanning. But they do some great stuff with application code and then running code as well, and checking for misconfigurations. Prisma Cloud, Palo Alto, formerly Twistlock, Redlock, Qualys, obviously in the vulnerability management space. These are all just some vendors that are in there, and there's so many more too. The open source ones, obviously, I wanted to give you a sneak peek of those. Here's an open source version of Claire, which is kind of an alternative to Trivy. You can just throw an image at it, and it'll tell you everything that's in it. All the vulnerabilities, all the CVEs, all the rankings, right there. Completely free, community-led, community-driven, and well-updated. Dockle, this was actually the first tool that I used probably like 5 years ago to understand, well, I have an image that I built, I just kind of was learning on the internet, and I built an image. I wanted to know, did I build it okay? Dockle told me, no, you didn't switch to root user, you didn't change this, you didn't get rid of that layer. And it was basically a linter for me to go, you didn't follow all these best practices, we're going to tell you how to fix those. So to wrap it up, I wanted to talk about a practical exploit. I can't even call it an exploit. It's a misconfiguration. Again, that's common, but a misconfiguration that allowed me to get root access to an AKS cluster all remotely. And I did that via service accounts within Kubernetes. So obviously, we all know what service accounts are, non-human accounts. In this case, they're managed by the Kubernetes API. They're time-bound. They're usually between an hour and 24 hours, somewhere in there, depending on how you have it set up. And what they do is they authenticate the pod to the Kubernetes API. And you might wonder, why does a pod running on the Kubernetes cluster need access to the API that is running it? Well, we'll talk about that. What happens is when you create a namespace within Kubernetes, a service account gets created, and a token or credential gets attached to that. Now, one caveat is up until 2 months ago, that was the action. You create a namespace, and all these defaults fell into place. They realized the problem here, and they stopped that last step. They didn't create the token and the credential and bind them to the service account. But if you want to use it for authentication, you have to do that. So the problem still exists. It's just you have to intentionally ignore their suggestion to not do that. So when you launch a pod, the secret gets mounted to this very specific path every time. And every container has that, and it's mounted securely. Kubernetes is managing that. And again, this allows us access to the Kubernetes resource. And for sake of time, I'm going to skip the authentication mode. But why would we need access to the resource? Did I skip a slide? I guess I didn't. Oh, yeah, I did. To create resources on the cluster. So let's go back to my GitLab example from earlier. If I want to create a runner to do a build pipeline, the GitLab installation on that cluster needs to create resources on that cluster for itself. And so it needs access to the API to create that. So it needs a service account with the proper permissions to create and delete and modify resources. Depending on what application you're running, you may have different sets of permissions required. So that's one example. You can read the rest, like service discovery. I need to pull the API to figure out what's out there. Itz.io and HashiCorp, Console, or all these products that are doing service discovery, they need access to the API too. For monitoring and logging, I need to be able to go into a cluster, or excuse me, into a container or a pod and look at logs, look at its resources and things like that. For the health monitoring, if I see it's under load, I need to scale out. So that's another way a pod or some system may require permissions to create or delete resources. So that's why it would need it. So then, how did I get here? Well, first, I'm not a pen tester, so I made an assumption that I had a web server. Let's just take like an Nginx server with a Postgres database. I had a web server with a vulnerability that I could access and get a shell. That was assumption number one. It was an easy one because, again, I'm not a pen tester, but there are projects out there that prove that happens, and we all know of examples. And then assumption number two was that there's a service account being used with too broad of permissions. Let me set some backstory to this. A lot of companies use namespaces within Kubernetes for an application. So all the components for an application all live in the same namespace, and that's how they kind of like segment things off. And again, to your point earlier about you thinking, oh, everything's segmented, it's isolated, it's secure. It's not really, because here's the point. When I launch an Nginx web server, that requires no permissions to the API, other than what it needs to report back to the API. But a Postgres database running on Kubernetes requires much more permissions. The reason why is it's a stateful application, and the Kubernetes API can't manage a stateful application because it doesn't know the lifecycle of the data within that application. It's stateful. So the database has a controller. It has a component that does all the managing for it. So it assumes the role of managing the lifecycle of its own containers. So if I assume everything in a namespace is all the same application, I can just use the same service account for that application, not Nginx and Postgres. Now I've gone and added a service account to Nginx with too broad of permissions. I've given it the ability to maybe create and delete resources, to switch into other pods and things like that. So here's the attack vector. I get the shell, that's assumption number one. I check the permissions of the token. Basically, I just download the kubectl binary. It has a handy function of can I, and you say kubectl, can I list pods? Can I exec to pods? Can I create certain resources? And it'll just say true or false. So I figure out, what are my permissions? Can I create a new resource? So let's say I get in there and the permission says, nope, you can't create resources, but you're allowed to switch into different pods. Okay, so and you're allowed to list other pods. That's a common one you'll see. So all I have to do is list the pods, find another one, switch into it, check its permissions. And basically, until I found one, a service account in that namespace that had the permissions to create a resource. So as soon as I had that, all I had to do was create a new pod that was running as root, it was running privileged, and the cluster didn't have any admission controller denying that activity. So that's, obviously you can see why that admission controller is important. So I created a pod running as root, and then all I did in the configuration was mount the underlying host root path or root file system as a path in the container. So now I have root for the underlying host root file system. All I had to do, get in there, change root, install a cron tab, ping out to my C2 server, and boom, I had root on an AKS cluster. So, and also depending on your permissions, you may be able to establish persistence. So within Kubernetes, you have something called a daemon set, which is a deployment that runs on every node in the cluster. So instead of having to hop from node to node to node and just doing all your investigation, check, can I deploy a daemon set? If yes, you deploy your attack pod to all the nodes and you have persistence because they're configured that if they go down, they come back up. So that's why having admission controllers and policies for what's allowed to run, what types of deployments are allowed to run is important. But that's how I was able to take all of these misconfigurations or common configurations that people don't lock down and get root on an AKS cluster. So hopefully with some fundamental knowledge and some practical examples, containers won't be a black box to the organization. So I do have a couple minutes for some questions. Yeah. It's hard to hear.
Many organizations, medium to large size, they'll buy an environment, have a hard gun from that environment, set it up and deploy it. How often do you see, and what would be your recommendation, where environments don't have a mature security staff, much less the container application people who own it?
Yeah, so the question...
To properly set the environment and the controls around it
So I'm going to come at it from like a merger and acquisition, and you have an environment that you're taking over. And what if that security? The question was, what if that security staff isn't trained up, and you want to move that deployment into a more secure environment or deployment? There was actually a talk yesterday that I attended that was fantastic, and they talked about a security champion program. And honestly, that's a culture thing. That's not a tooling thing. If you went to that talk, it was fantastic. I'm blanking on his name. He's from Exxon, but it was fantastic. But it's a culture thing. That's a security culture. But there are top down. But there are any number of ways to approach it. But in my opinion, starting with culture and then finding the right tools to back up that culture.
But how have you had success where, I mean, your organization has a lot of expertise, yourself included, in having organizations say, you know what, we don't know it all. Let's hire XYZ to come in and mentor us and work side by side to set up our environment and get the controls in place.
Yeah, so finding a good partner. So the question was, what do you do? Yeah, what do you do when you you need to find a partner? Obviously, I work as a partner, so find someone who's knowledgeable in that. Partner with vendors who know this space. So that slide, any one of those can give you good information. But yeah. Any other questions? Yeah.
So I've seen a lot of scenarios where security will tell the dev, like, hey, this image has vulnerabilities, like,
Sure.
get rid of it, whatever. But they don't realize the vulnerabilities are coming upstream from the base image, and they just build a new image that inherits those same vulnerabilities again. So what are the best practices to prevent that from happening?
So the question is around your upstream vulnerabilities from importing from other images from other companies, and how do you fix that? Well, the easy answer is to redevelop the image yourself. Partner with whoever is developing that base image that you're using. Offer your resources to help. Maybe they just haven't maintained the project. But more often than not, the best case scenario, and this is really hard for developers to do, what you're better off doing is building from either scratch images and building everything from the ground up, or using images from like Wolfie. ChainGuard is the SaaS version of their product. Or Google has their distroless images, which are extremely bare minimum, that you're basically building everything from the ground up. So in the long run, that's the better way to go. In the short run, see if you can, if it's open source, fork it and update the application code, or partner with them. If it's not open source, you don't have access, offer your resources to do that. But in the long run, rebuilding the image from like a distroless or a Wolfie ChainGuard image, in my opinion, is a better way to go. Any other questions? Speak now, forever hold your peace. All right, well, thank you very much. Appreciate you guys. Have a good lunch.